Good morning, everyone. Today we're going to talk about explicit formulas for sequences. So last week we did recursive formulas, which depend on other terms in the sequence. Today the formula doesn't depend on anything. You could just plug into it. So let's get started with arithmetic. This is the formula for an arithmetic explicit formula. And all the things still stand for what they stood for before. A sub 1 still stands for the first term. D still stands for the common difference. And N, so we see N two places. We'll see it here and inside the parentheses. N stands for the term that you're looking for, or that you're trying to find, that you are finding. So in two places, here and here. But you'll notice that it's kind of long and it has parentheses in it. Once it's simplified, that explicit formula for an arithmetic sequence is actually going to be a linear function. So you remember when we had linear functions y equals mx plus b? It's actually going to simplify to something really similar to that. So let's go straight into our examples. So for the examples it says, find the explicit formula for each sequence and then calculate the terms shown in the problem. So number 1, this is an arithmetic sequence. So the first thing I need to do is find my common difference. So from 12 to 19, how much did they have to add? So it's plus 7. And make sure that it's the same every single time. So from 19 to 26, it's also plus 7. And from 26 to 33, it's also plus 7. So this means that 7 is our common difference D. The other thing that we need for the formula is our first term, which is 12. So that's going to be our A sub 1. So now if I follow the formula, this one right here, I have A sub n equals A sub 1 plus D parentheses n minus 1. So what we're going to write is A sub n. Our A1 for this problem is 12. Our D, our common difference, is 7, so plus 7, parentheses n minus 1. But once we have that, we want to simplify that as much as we can. So I'm going to distribute this 7 to everything that's inside the parentheses. So that would give me 7 times n is 7n. 7 times negative 1 is negative 7. Okay, but then from here, I have to combine my like terms. The 12 and the negative 7 are both constants, so those can be combined. So I have 7n, but 12 minus 7 gives me positive 5. So this is my explicit formula for this sequence. The other thing that it wants us to do is find A8, which means that it wants us to find the 8th term. So all I have to do is get that 8 and plug it in wherever I see the n. So 7 times 8 and then plus 5. So if I just put that into my calculator, that gives me 61. So A sub 8 equals 61. Okay, let's do our second example. 13,951. So our first term, our A sub 1, is going to be 13. That's a sub 1. I need to find my common difference. So to get from 13 to 9, since it's getting smaller, they're subtracting something. How much are they subtracting? Okay, it is minus 4. Make sure that it's the same every single time. So from 9 to 5, also minus 4. From 5 to 1, also minus 4. So that is our common difference. So now that we have the two things that we need, we're going to plug it into the explicit formula. So that's a sub n equals a sub 1, which is 13. Then our common difference, which is minus 4, parentheses n minus 1. Then we want to simplify as much as we can. So this negative 4 needs to get multiplied in. So negative 4 times n is negative 4n. Negative 4 times negative 1 is going to give me positive 4. Then we combine our like terms. So we have negative 4n plus 17. That is our explicit formula. Okay, next it wants us to find a sub 10. So what would be the 10th number in this sequence? So I'm going to plug in 10 for n. That gives me negative 4 times 10 plus 17. So again, this is just a calculator problem. And I get negative 23. Okay, and one more example of arithmetic. Negative 8, negative 5, negative 2, positive 1. So negative 8 is our first term, our a sub 1. Now, these are negatives, so be careful. Negative 8 to negative 5 to negative 2. As you move this way, the numbers are getting bigger in value, so we're adding something. How much would we have to add to negative 8 to come up with negative 5? Okay, that would be plus 3. Make sure that it's the same every single time, and it is. So that means that that is our common difference. Okay, so let's write our equation, our formula, starting with a sub 1, so starting with negative 8. Then we put our common difference, so plus 3, parentheses n minus 1. We want to simplify that, so let's distribute the 3 inside of the parentheses. So that would give me plus 3n minus 3. Then we're going to combine those like terms. So that would be 3n, and negative 8 plus negative 3 gives me negative 11. That is my explicit formula. Now let's find a sub 7. So all we're going to do is plug in 7 anywhere that we see an n. So 3 times 7 minus 11. Put that into our calculator and we should get 10. Okay, so that is how you work on arithmetic problems. Like I said, these are actually linear functions. So this would count as your slope and your y-intercept. So it should look very, very familiar to you. Now let's go over a geometric sequence. Okay, so the geometric explicit formula is a sub n equals a sub 1. Again, that still stands for the first term, times r, that's our common ratio, to the n minus 1 power. And n here, same as the other one, stands for the term that you're looking for, or a term that you're trying to find. Okay. So once simplified, the explicit formula for a geometric sequence is an exponential function. So this is the one that we just finished learning. This is section 8. We learned this all online. I remember the parent function for that was a times b to the x power. So it's still the same thing. We're just using different letters, but it's still the same function. So let's look at examples of geometric sequences. So I'm starting with some big numbers. 729, 243, 81, 27. So let's start with the most obvious thing. We know that the first number is our a sub 1. So now we need to find our common ratio. So notice that the numbers are getting smaller. So our common ratio is going to be a fraction. But how do we find what it is? This one's a little bit harder to see. Well, you set it up as a fraction. So second number 243 divided by the first number 729. Okay, so this is big numbers. I want to see if that'll reduce down to smaller numbers that I can work with. So you can go to www.desmos.com/scientific and it'll get you a calculator. So when I type this in, this simplifies to 1 over 3. So basically what they're doing is dividing by 3. And just double check that it's the same every single time. So 81 divided by 243 is also 1/3. And 27 divided by 81 is also 1/3. So this is our common ratio. So now all we need to do is set it up. So we're following this right here. So it's going to start with a sub 1 times r to the n minus 1 power. Okay, so that would give me a sub 1 is 729 times r, so I'm going to put that in parentheses, 1/3 to the n minus 1 power. Okay, so in this case, we're not going to simplify it anymore. It's just going to stay like that. That is our explicit formula. But now they want us to find a sub 6. So what we're going to do is plug in 6 anytime we see an n. So it'd be 6 minus 1. But then what is 6 minus 1? We know that that's 5. So just plug it in to our calculator. Okay, and see when I type it in, I get 3. So the sixth term in this sequence would be 3. Okay, let's move on to the next one. 6, 12, 24, 48. So we need our a sub 1, which is the first number. But now I need to know our common ratio. Since the numbers are getting bigger from left to right, so 6, 12, 24, it's going to be a whole number, or it's going to be bigger than 1. So the way I figure out what number it is I get the second number 12, and I divide it by the first number, and that gives me 2. So basically what they're doing is they're multiplying by 2 every single time. 12 times 2 is 24. 24 times 2 is 48. So that is my common ratio. So let's write our explicit function. A sub n equals 6 parentheses 2 to the n minus 1 power. Then it wants us to find a sub 5. So we're going to plug in 5 anywhere that we see an n. So it'd make my equation look like this. Then I'm going to figure that out. What is 5 minus 1? That's to the 4th power. So I'm going to plug that into my calculator. 6 times 2 to the 4th power. And I get 96. So 96 is the 5th term in this sequence. Okay, and one more. Okay, I have 2, -4, 8, +16. So this one is kind of tricky because if you look, every other number is negative. So it goes positive, negative, positive, negative. But that doesn't mean that it's not a geometric sequence. You just got to be more careful. So we know the first number is a sub 1. But what is our common ratio? What are they multiplying by? So same as before, get the second number divided by the first number. That gives us -2. Make sure that that's the same every single time. What is -4 times -2? Well, negative times a negative makes it positive, so we know they're multiplying by -2. Then here to here, 8 times 2 is 16, but because we're using -2, that's -16. So this is our common ratio. So our formula would be a sub n equals our first number 2, parentheses our common ratio -2 to the n minus 1 power. Then they want us to find a sub 10. So we're going to plug in 10 anywhere that we see an n. Okay, so what is 10 minus 1? That would be to the 9th power. Plug that into the calculator. 2 times -2 to the 9th power gives me -1024. Okay, and that is it for explicit formulas of sequences. If you have any questions over this, feel free to send me a message on Google Classroom or on Remind.